My name is Julie Graesch. I am a biological program manager responsible for insect management products at Bioworks. And today I'm going to be talking about EPA registered insecticides and compatibility with biological controls. Let's start with a quick presentation overview. We're going to go over the IPM toolbox. Then we're going to talk about pesticides, pollinator safety, and market trends. And that will set the stage for the compatibility discussion on both biopesticides and natural enemies. And we're going to end the presentation by talking about integrated IPM programs. Let's start with IPM. So it's really important when doing a biological program that you have a preventative mindset. There are a lot of things that you need to do before you reach for one of the products that you're going to buy, like a biopesticide, a natural enemy, or a chemical. And not only do you need to do that before, but you need to do that constantly. So these are just running in the background to control pest populations. These are things like scouting and monitoring, and this is really important to ensure that you are identifying the pest population and the species that you're dealing with as soon as it happens so that you can make appropriate decisions on what products you need to purchase later down the road if you need to do that. Sanitation is a cornerstone of any integrated pest management. I could spend an entire presentation just talking about sanitation. And having good sanitation will not only help with diseases, but will also help with insects. So make sure your sanitation program is operating in the background and is very good. This is things such as cleaning up crop residues, disinfecting benches, tables, drip lines, and so on. Exclusion, which is fairly self-explanatory. If you're growing indoors, if you're growing outdoors, it's not necessary. There's not much you can do about it. But indoors, you want to screen your vents and that will help reduce at least the bigger pests. Even thrip screening can let thrips in. So sometimes some pests are going to be inevitable. But pests can also come in on your workers. So there's another opportunity to exclude pests coming in on people by using clothing provided for by the company and so on and so forth. The other thing with exclusion is when you do get a hot spot, understanding why that hot spot occurred so that you can potentially fix the problem that is allowing that hot spot to happen and prevent it from happening in the future. Cultural practices are important, such as mass trapping, so long sticky tape to trap any adult insects. Irrigation and fertilization are important. If you over-irrigate, you're going to get things like algae or wet roots, and those wet roots can cause your plants to start to lose root hairs and roots, and that can be a food source for things like fungus gnats or a breeding ground for pathogens. Also with fertilization, although I'm not going to really be talking about this in this presentation, if you over-fertilize your crop, you are also providing a very nutritious source of plant material for your insect populations, and your insect populations can actually be worse by over-fertilizing. So there's some really good data out there on this, and if you're interested, just let me know, and I can get you that information. So when all of these other things going on in the background of integrated pest management, you could do everything right, but a pest population, especially in the summer months where everything is right, temperature and humidity, you can have spikes in pest populations. So that's where you would want to start by reaching for either your biopesticides and or your natural enemies. Biopesticides, for example, are entomopathogenic fungus, oils, soaps, and naturally derived pesticides. You can also reach for natural enemies. These are your insect or mite predators and parasitoids, also beneficial nematodes. And what you choose here will depend on the insect species that you are seeing in the greenhouse, and it's extremely important to make sure you properly ID what species you have, and of course also the severity. If you have really high populations of insects, you may want to reach for a biopesticide to bring the population down before you reach for your natural enemies. And finally, after you do all of these things, if you still see a really high pest population, that's when you want to reach for the insecticides. So in this presentation, we're going to talk, of course, more about the biopesticides, the natural enemies, and the chemical insecticides. And of course, in the last part of the presentation, talking about compatibility and programs. What I want to make sure I get across is that when we're talking about integrated pest management, it does not mean that you can't use insecticides, the chemical insecticides. It just means that we need to have really intelligent timing and use of the chemical insecticides, so that one, we prevent pesticide resistance, insects becoming resistant to the pesticides, and preserve the natural enemies and pollinators. I'm going to talk about two main types of programs. The first one being a pesticide rotation or tank mix program, and two, a natural enemy pesticide program. In either one of these types of programs, compatibility is crucially important, which is why we're going to be spending the second half of our presentation talking about compatibility. Before we get there, I want to talk about pesticides, pollinator safety, and market trends. So let's start with conventional insecticides. This chart is from the Technical Reference Guide for Greenhouses and Nurseries from GGS Pro. And this is a fantastic resource. If you are not familiar with it, I would highly recommend. So here we see a list of different mode of action chemistries that can be used on whitefly for both ornamental crops as well as edible crops. So you can see there are fewer options available when you are getting into the edible market. So you'll see also MOA, and MOA stands for mode of action, and that is how the particular pesticide works on an insect, how it controls it. So anytime you're using chemical insecticides, you want to make sure you rotate at least 3 to 5 different mode of actions. And you never want to use a particular mode of action more than 2 or 3 times in a cropping cycle. And of course, that information will be contained on the label on how many times you can use it and on what pests. So the other thing that I wanted to mention in this chart are your biopesticides, which are now circled in red. And those are in the mode of action group UN, and UN stands for unknown. It's unknown because these are your biologicals. And biology is messy. It is it's complicated. And so you can have some of these things that have multiple mode of actions or really complicated mode of actions, or even physical mode of actions such as suffocation. And these biopesticides they don't care if an insect is resistant or not. They're non-selective in that nature. So if you have an insect that is resistant or not resistant to a particular pesticide, by rotating in these biopesticides, you will also help manage a resistant population if you're dealing with it. So it's really important to consider using these biopesticides in your rotation or your chemical rotation program. Now that we talked about the conventionals, let's talk about the natural enemy side. So here I have listed 5 of the most notorious pests that we deal with in greenhouses and nurseries and specialty ag. We have our thrips, our aphids, whiteflies, mites, and fungus gnats. Under each one of the main pest category, you see a list of natural enemies. And it's important, just like we talked about earlier with integrated pest management, it's important to come at a pest population with the pitchfork approach. So coming at it with multiple control agents. If you use just Aureus for thrips, those are mainly just targeting your adults and maybe some of your larvae. They're not going to go for other life stages. But if you start incorporating Amblyceus mites, they're going to go after your L1 stage of your thrips. Aureus are going to go after your adults. Stratiolaelaps and Delocia are soil predators. And by having those in the soil, if you have a thrip that pupates in the soil, and not all thrips pupate in the soil, they're going to target any life stage that the prepupa stage that falls to the soil, and these soil predators will then go after that. And Steinernema feltii is also a soil parasitoid nematode. So as you can see, there's all these different predators and parasitoids for a single pest organism, which is what you need if you are using a natural enemy program. And we're going to, when we talk about the final topic in my presentation, I'm going to show you how that may look. Let's talk about market trends. Why are we talking about biologicals? Well, they're growing a lot faster than the chemical market. This information comes to you from Dunham Trimmer, which is an international biological intelligence company. And in this chart, we see billions of dollars in your vertical axis and year in the horizontal. And the year from 2018, so we're looking in the past, to 2030, which we're looking in the future. We also see three markets. The blue line is the biocontrol market. Those are your biologicals, your biopesticides, and your natural enemies. And this market is growing by 13.6 compound annual growth rate, CAGR. The biostimulant market is growing by 12% CAGR, and the biofertilizer market is growing by 12.5% CAGR. So you can see that all three of these markets are growing rapidly. In the last 10 years, biocontrol market has grown by 2 to 3 times faster than that of the chemical crop protection market. And the chemical crop protection market is growing by around 3%. If you want to see a video, I did include a YouTube link here. If you just Google Farm Foundation Forum, Biologicals and Agriculture Innovation, Science and Promise from June 2021, Dunham Trimmer does a really nice presentation on this. So getting back to the market trends, I mentioned that synthetics are growing by approximately 3%, and biologicals, now this is encompassing everything, is growing by approximately 12%. So Upstream Ag Insights' Shane Thomas did a presentation earlier this year, and he looked at the CAGR for both of these markets, 12 and 3%, and if it stayed the same year after year, how long would it take the biologicals market to reach that of the synthetic market? And from this analysis, he found that in around 20 years, the biological market will equal that of the synthetic market. So it's really important to start considering the use of the biologicals because it is growing much faster. And there's also some challenges with the synthetic market, which we are also going to be talking about. So I want to talk a little bit more about why the market is trending to biological control. One of those reasons is just health and safety for plants, workers, as well as the environment. Biological controls typically have no or low restricted entry intervals, pre-harvest intervals, and maximum residue levels. Those MRLs are really important if you're dealing with the cannabis and hemp market or at the edible market, because that's people may be consuming those and you don't want to have pesticides in or on them. Biological control, the biopesticides have also become a lot better at controlling insects than in the past, better formulations, better organisms. So oftentimes you can get similar efficacy with your biopesticides as your chemical pesticides. Consumer demand. People don't want pesticide residues on their crops and they're looking for organic options. And finally, pest pesticide resistance. And rather than talk about that now, I'm going to cover these two topics in a little bit more detail. There has been a lot of phasing out of pesticides. You may have heard about it within the United States as well, although we are further behind in the United States than Europe and Canada. In Europe and Canada, in fact, they have restricted or banned many pesticides, and even some of the biopesticides, such as pyrethrins, which are the botanical form of pyrethroids. In the US, we have started taking the right steps in restricting the use of some of the pesticides that are mainly very broad spectrum. Walmart, a year or so ago, moved to protect pollinators, and in their pollinator policy, they vowed to source 100% of their fresh produce and floral inputs from growers who are using integrated pest management by 2025. In this policy, Walmart is asking growers to phase out chlorpyrifos and neonicotinoid chemistries and not replace those chlorpyrifos and neonicotinoids with other level 1B precautionary pesticides. So what is a level 1B precautionary pesticide, you ask? There is a website for that. As you can see at the very top, this is a really useful website. And basically you can just put in a product name, a brand name, or you can also put in the active ingredient, and it will give you a list, or it will tell you if it is a level 1, a level 2, or a level 3. A level 1, of course, are your chemistries that you do not want to use with bees. They're very toxic. A level 3 is no bee precaution, except when required by pesticide label regulations. So you'll want to be using chemistries in the level 2 and 3. And I gave you an example of what the list would look like if you were to look up a list of different things. Okay, so the next thing I wanted to talk about is IRAC. And IRAC stands for Insecticide Resistance Action Committee, and you can see the website there, http://iraconline.org. This is a fantastic resource. If you are not familiar with it, you can get a lot of information about insect resistance. I also included FRAC here, which is the Fungicide Resistance Action Committee, and this is going to give you information about your fungicides, similar to what IRAC would show you. So if we look in IRAC, you'll see that there are approximately 30 chemical mode of actions, MOA, and around 7 unknown mode of actions. If you remember what we talked about earlier, the UN, the unknowns are those biopesticides such as entomopathogenic fungus, oil, soaps, and naturally derived pesticides. If we just look at our three of the most prevalent insects, western flower thrips, Bemisia whitefly, and two-spotted spider mites, they're around a third of the chemical mode of actions have resistance issues. And there's likely more adding onto these lists as we become more limited in the crops and the pesticides that can be used. So it's important to, again, rotate in these unknown biopesticide mode of action groups to help you prevent the development of resistance in your insect populations. This is all to say that biocontrol may eventually choose you. So before you are, I don't want to say forced, but before you are required to use biological control, start playing around with it now. Start incorporating it and learning how to use them in your program. And you will see that biocontrol can work in your operation as well. But there is a lot of learning that needs to occur. And hopefully this is going to contribute to your learning journey in using the chemistries with your biopesticides and natural enemies. And of course, by doing that, we need to make sure that we consider compatibility because it is incredibly important. So there are a lot of different inputs that growers can use in their greenhouse for arthropods, diseases, nematodes, weeds, and mollusks, which are your snails and slugs. Whichever product or organism that you are trying to control, if you are going to be using one of these chemical pesticides, you need to make sure that it's going to be compatible with your microbial biopesticides and or natural enemies if you're using them. So you need to check all of your inputs. So we're going to talk about compatibility, and I have several things that I'm going to touch on in this section. So a little bit of an overview. We're going to start by talking about the importance of doing compatibility, understanding compatibility, and I'm going to do that by showing you a couple of research studies. We're going to talk very briefly about physical compatibility, which most growers are familiar with. This is what we call a jar test. pH is really important because some pesticides do require a very specific pH maintained in the spray tank in order for full efficacy. So if you spray a really high, if you put in a potassium bicarbonate, which has a really, really high pH, and then you add an acid to it, and try to neutralize that water pH, you will be negating the efficacy of the potassium bicarbonate because it requires that high pH in order to change the pH on the surface of the leaf, which makes an inhospitable environment for disease development. So it's really important to make sure that you check your product label to ensure that you are not damaging your biopesticides in the spray tank. And finally, microbial compatibility. And I'm going to show you a little bit about what we do at BioWorks when we do microbial compatibility. And we do two tests. We do a tank mix and a spray test, which is like a rotation. So I'm going to talk about these two categories a little bit more detail. As I mentioned, with physical compatibility, you're looking for things like separation or heat development, steam, flocculation, precipitation, anything, and that's pretty easy to see, and it typically happens fairly quickly if a chemical mix is not compatible. So that's pretty much what I wanted to say about that. So if we now talk about the importance of compatibility, so this is a study that was done on the efficacy of biorational insecticides against chili thrips infesting roses under nursery conditions. Here they looked at, if we look at these graphs, we have weeks after spray and thrips per sample on each of these. And in the top one, we just have a biopesticide rotation, is the group here, a spinosad treatment all by itself, and the line up top is that of the control. So our control, we have an increasing population, and you can see all of our biopesticides, which are either rotated or tank mixed, are doing pretty much a similar job in managing chili thrips. So these are all, of course, compatible, because if you would see, if they were incompatible, you would see a difference in the level of control that you're getting. The other thing I wanted to mention is the arrows signify that of applications. So 4 applications are being made. What's important is the graph here on the bottom, which is now using the biopesticides, either tank mix or rotated with the spinosad. And you can see that again, your control, you have exponential growth in 4 applications, but now all of our biopesticides has a similar curve to what we saw with the spinosad treatment down below, or I'm sorry, up above. You are getting much better control when you're rotating the biopesticides with spinosad. Of course, you would not see that if the biopesticides that you were either tank mix or rotating were incompatible, because you would be killing those microbials and you would then only be getting the efficacy from the spinosad. The other data that I wanted to show you on compatibility importance is this data. This is percent mortality of Bemisia tabaci, which is the silverleaf whitefly on eggplant. And we have 2 other treatments in here. We have Bavaria bassiana, which is an enema pathogenic fungus, and neem oil, which is azadirachtin. It's an insect growth regulator. So the line on the bottom here is that of the check. So you don't have any mortality in your check group, which is what you want to see. And then we have 2 lines here in the middle, which signify the biopesticides, the Bavaria and the neem oil applied by themselves. The solid line at the top is that of the tank mix of both the Bavaria and the neem. And you can see not only are these compatible because you get additional mortality, but there may also be a synergistic effect of the tank mix because we see an increase in mortality when tank mixed versus using these separately. About a 20 to 28% additional mortality when combined in the case of this study. The next thing I wanted to share with you is what we do at BioWorks. We do a lot of compatibility studies, and I wanted to show you what this may look like when working with the microbials. So let's start with the compatible. So here we have 3 Petri dish plates with no growth. This is your water control, so you don't want any growth on these. Next, we have Botrystop. This is Euclidium udamancii. This is a fungus for management of things like botrytis. And you can see that the relative number of colonies and size of these colonies, this is what you're comparing your tank mix with in terms of size and number of colonies. So this is what you want it to look like. So in this case, we've tank mixed the Botrystop Euclidium udamancii with Gatton, and you can see that the number and the size of these colonies did not change. So therefore, and this at a low and a high rate, is compatible with this particular fungicide. Now, if we look over at incompatible, once again, we have our water. We don't want to have any growth on there. We have the Botrystop again. And again, this is our control. So we did not tank mix it with any chemistry. Now, when we tank mix it with fungicides such as Pageant, you see no growth of the fungal organism. So in this case, it would be incompatible to tank mix. If you look at the compatibility guides, it may give you a spray interval in which you can apply how long you would need to wait to apply the Botrystop after a Pageant application. The other thing that we do is a rotation. So maybe you aren't going to tank mix it, but you want to use it in rotation. And you could still affect a fungus population on the plant if you apply a chemistry too soon after that application. So once again, here over on the compatibility side, you have your water. And in this case, you do have your Botrystop Euclidium fungus growing, and we have sprayed water on top of those colonies. In the case of the other 2 sets of plates, we have sprayed gatton on top of the actively growing populations, and you can see there is no impact. But that's not necessarily the same case for Mural. On the incompatible side, you can see that it didn't completely kill it, but it did inhibit its growth. So you may just need a longer spray interval before you would need to before you could spray the Mural after a botry stop application. So it is important understanding compatibility when using microbials. Here's an example of compatibility resources at BioWorks. There are other companies, and they will likely also have compatibility resources, and I will have a resource page at the end. But if you go to our product pages, you'll see a link to the compatibility guide, and it will bring up a list of what you can or cannot tank mix. Okay, now that that's done, let's talk about natural enemy compatibility. If you're using natural enemies, even a water spray can affect your natural enemies. So before you spray anything, you need, when using natural enemies, you need to consider a few things. Has the tipping point been reached? So in the case of the picture here, you can see a lot of insects on this slide, and it looks messy and scary. But if you're familiar with biological control, you can see that the majority of these aphids have been parasitized by wasps. And you can even see the exit holes of those wasps that have emerged from those aphid mummies. So this battle has been won. Yes, there's still a few aphids out there, but the majority of the aphids have been killed. So if you were to spray this plant with something, you would actually mainly be killing your natural enemies, and that's not what you want to do. So has your natural enemy army won? Understand that, and you can understand that by having a really good scouting and monitoring program. You may also want to increase, if you see this and you still see a few aphids, you may want to consider increasing a release or in either rate or frequency of release of your natural enemies. You may also want to switch or add an additional natural enemy. There are some more curative options with natural enemies that, such as like the mealybug destroyer, which is a Cryptolaemus, and it's a beetle that will go around and start munching on a whole bunch of mealybugs relatively quickly. So there are some options out there to help you manage the population if you're not currently using that natural enemy. And finally, you can use biopesticide spot treatments. So if there are hot spots, rather than spray the entire greenhouse with a biopesticide or a pesticide, come in with a biopesticide that is relatively safe for your natural enemies and just treat the areas with the highest insect population, so you preserve the greater natural enemy population. Just like with the biopesticide, there are a lot of different places that you can go to get compatibility information for natural enemies. IOBC has a plethora of information. However, this is a paid for subscription. It is a yearly subscription, but it is not, I think it's only like $100, 100 euros. So it's not a large investment. Or you could ask your your natural enemy supplier to look up this information for you, because ideally they would have this subscription for you. So you can also go to your supplier for this information. BioBest and Copert also have a really good side effects database, as you can see here. What these databases tell you is the mortality of the insects, your natural enemies to a particular chemistry or mode of action. What they don't really tell you is sublethal effects. And it's really actually difficult to study this. And I'm not going to spend a lot of time talking about it, but I do want you to be aware that there is a whole nother category aside from just the mortality of your natural enemies, that you may be affecting your natural enemies through your sprays of pesticides and sometimes even the biopesticides. You can have physiological effects on your natural enemies, delays in development, shorter adult longevity. You could affect their immune system, so they're not able to fight off pathogens. Fecundity, which means that their ability to reproduce, if they can't reproduce, that's obvious, that's obviously a bad thing. Or sex ratio. If you female wasps are the wasps that are going to be laying eggs in aphids or whiteflies, and if you're mainly producing males because there was a sex ratio shift, that's a bad thing. You can also have behavioral effects, mobility, navigation, and orientation, which of course is a problem with our bee community. If you if they consume neonicotinoids, it can affect their navigation and orientation, and they can't get back to the hive, and they will perish because of that. Feeding behavior, oviposition behavior, and learning performance. So there's a lot of different things in this sublethal effects. Many studies have documented sublethal effects. However, when you look at these compatibility guides for natural enemies, you were only looking at the mortality. That being said, there's a fairly standard key that you will see with all of these different compatibility guides for natural enemies, and it's a scale from 1 to 4, with 1 being somewhat compatible, and it's somewhat compatible because even water can affect your natural enemies. Your 2s are going to be your IPM tools. These are going to be slightly toxic, but has a place, short to no residuals. Your level 3s are cleanup or spot sprays, and 4s are never being used with your natural enemies. So I just touched on it here. There is, I just wanted to make sure you understood this, because as you navigate these compatibility guides, it's important to understand what you're looking at. So I wanted to go through each one of these categories briefly. So a 4 is highly toxic to natural enemies. It's going to kill both natural enemies and your pest alike. Other than that, the other main issue with your never should be used with natural enemies is that these chemistries can persist for months. Examples would be marathon, orethine, duraspan, permethrin. These are in the IRAC groups 4, 1, and 3. And you can see what, if you go to the BioBest or the Copert side effect website, you can see once again the 1, 2, 3, 4. Those 4 in red are those never should be used. So it's fairly easy to see and understand these once you know what to once you understand that chart of 1 to 4. Sometimes you can even see over here with the marathon and imidacloprid, some of the chemistries, if drenched and the drench does not contact the foliage, as you can see here, the drench is compatible with the natural enemies, but not all natural enemies. If the natural enemy is sipping from the plant, the natural enemy will still be killed by that chemistry, even if it is completely within the plant. If you spray it, highly toxic. For your 3s, these are cleanup and spot sprays. So these do have a fit. These are moderate toxic to your natural enemies. These are typically persisting for 2 to 3 weeks. And the persistence, that means that if you apply a natural enemy within that 2 to 3 week period, you will still kill that natural enemy. Examples would be avid and pylon in the IRAC groups of 6 and 13. For your IPM tools, these are slightly toxic and they have a place in integrated pest management with your natural enemies. These have short to no residuals. These are examples are your soaps, your oils, your botanicals, Ventigra, Mainspring, Contos, and Endeavor. And you can see the IRAC groups. So a lot of your biopesticides are going to be in the IPM tool group. Just because they're a biopesticide does not mean that they're going to be safe for your beneficials, but the short to no residuals means that you can knock back a high population of insects and be able to come back in with your natural enemies right away. For your somewhat compatible, again, I said even water spray can kill natural enemies. So these are your non-toxic with minimal sublethal effects, since we talked about sublethal effects. And these, once again, have short to no residuals. And these are going to be pesticides such as microbials and botanicals in the biopesticide IRAC unknown groups. This is unknown bacteria, fungus, mechanical disruptors. Okay, now on to our final topic, which is integrated IPM programs. So I just want to show you in a couple of examples what an integrated program would look like with natural enemies and pesticides and biopesticides. So this is an infographic from Vineland Research and Innovation Center that was developed a few years ago, and it shows a really nice depiction of a program for targeting thrips in chrysanthemum. So here we're starting with a dip, and dips are important because if coming from another country, say offshore or even within the United States, you could have pesticide residues on those plants, which means that you may also be getting pests that are resistant to chemistries from the get-go. So by starting as clean as possible and reducing the number of pests that you have coming in by quarantining as well as dipping, you will do yourself a favor. So you can start cleaner by doing dips, and then when in propagation, you can start doing mite broadcasts as the plants get transplanted into bigger pots, continuing to broadcast and or adding sachets. You could start doing some biopesticide sprays that are compatible with your natural enemies, and also starting to add your soil predators. This is Stratiolaelaps and Delocia, the rove beetle, and a predatory soil mite, as well as your nematodes, your beneficial nematodes that are going to go after things like fungus gnats and thrips pupae. As the plants get larger, adding sachets, potentially either hanging or on a stick, continuing to do biopesticide sprays, adding additional natural enemies such as aureus that are going to go after, they're very voracious predators of thrips. They kill thrips and don't even eat them. It's pretty crazy to watch. And then finally, if required before shipping, if there are higher populations of insects, or if for whatever reason you need to do a spray before it leaves, you could do so. You will be killing the natural enemies, but that are on that plant, but it may be required to do so, and they'll be going to your customer anyway. Just make sure that the customer that you're sending those to are aware. Especially if they're going to finish the crop, if they're going to continue the biocontrol program, they may not want you to do those cleanup sprays. This is another example looking at thrip population, and again, this gets back to the pitchfork approach that I mentioned earlier with all the different natural enemies that can be used. This is an example of a thrips life cycle. at 86 degrees Fahrenheit, the approximate time it takes the insect to go through each one of these development life stages. And we have different predators and parasitoids for each stage. For the egg, there's not a whole lot that can be done by that. For the egg, because the egg is placed inside the leaf tissue, and you can see those little white dots are that of thrips eggs being placed into the tissue. However, you can suffocate them with something like a horticultural mineral oil or a soap. So you can help control the egg stage. For your larvae, your smallest L1s can be targeted by predatory mites such as Amblysia swarovski and Cucumaris. Aureus will also feed on the larval stage. For your pupae, as I mentioned, in the soil, if the thrip pupates into the soil, and onion thrips and western flower thrips and tobacco thrips are all thrip species that will pupate in the soil, you have an opportunity to target those with the rove beetle, the predatory soil mite, and the nematodes. And for your adults, you could use beneficial nematodes, although that can be a little bit more challenging, but Aureus is a good control agent for your adults as well. And of course, don't forget about your biopesticides and your chemistries that are compatible with your natural enemies. I circled Amblysia swarovski, which is a predatory mite, up here. And if you also had, say, whitefly on the same crop, Amblysia swarovski will also feed on eggs and L1 of a whitefly population. So this would be, Amblysia swarovski would be a good option to use if you had both of those pests. Some specific parasitoids for whitefly is Encarsia formosa and Aromacerus eremicus, and they are going to be targeting different life stages and putting an egg into these different life stages. They may also be doing something called host feeding, where they will stick their mouth parts into the whitefly larvae and be drinking the juices, and they will kill the whitefly doing that as well. So there's a dual effect of both parasitism and host feeding. You also have a couple of different general predators here, which is Dicyphus hesperus and Delphastus catalineae, that will also target your adult stages, since the other predators that I just spoke about will not. And of course, you also have your compatible biopesticides and chemistries, oil, soaps, mycoinsecticides, botanicals, Ventigra, Mainspring, Contos, and Endeavor are also fairly compatible with biological, your biological control agents, your natural enemies. So to review, when using an integrated pest management program, and this is purple flash pepper, which is used for an Aureus banker plant for management of thrips. You want to make sure you have really good scouting and monitoring. Make sure you properly ID your pest. When the pressure is high, reach for your biopesticides, because that is going to help your natural enemies in the long run, because they have to build their population up in order to respond to a high population of their pest or their prey. So it does take them, they're lagging. So if you can help them out by knocking back some of the population, you'll be helping your natural enemies. Dipping once again to start clean. Understand compatibility, so you're not just torching all of your natural enemies or killing your myco-insecticides. And spot treating is your friend when doing natural enemies. Treating those hot spots so they don't spread, and so that you manage those insect populations before they become a problem widespread. So the take-home message here is, when using natural enemies specifically, ask not what your natural enemies can do for you, but what you can do for your natural enemies. Ask yourself, not what can I still spray, but change your mindset to how do I avoid spraying? Because as I mentioned, natural enemies are impacted in some way, shape, or form by all inputs. So as much as possible, try to avoid spraying when you can. Again, get comfy with compatibility because that is going to save your biological program. It can make or break it. And finally, timing is everything. If you are going to be doing a natural enemy release, but you want to knock back any population before you do so, go out with a horticultural oil first. Spray down the crop to knock back the population. The next day, then you can release your natural enemies, and they're going to be working for you without being impacted by that biopesticide spray. With that, I mentioned that I had a compatibility slide. This is a number of resources that I used in development of this presentation. A lot of different resources on this slide on compatibility. Also, on the second resources slide, there is information about integrated pest management from a variety of different websites. Also, IRAC, I believe IRAC and FRAC is on there. So a lot of the resources that I spoke about in the presentation are on here as well. If you would like to get a list of those resources, I do have a Word document that I would be happy to send you. My contact information is on the screen, jgraesch@bioworksinc.com. Thank you very much for listening to my presentation, and I hope your biological control program is successful.